Welcome to this explainer. Today, we are going to unpack a massive, hiding in plain sight mystery about exactly how we measure speed in the modern world. We're looking at an absolutely incredible piece of 400-year-old engineering that is literally flying over your head right now.
Okay, let's dive right into this. Picture a modern passenger jet tearing across the Atlantic Ocean at a blistering 550 knots. Now picture a massive steel cargo ship steadily pushing across the Pacific at just 18 knots. These are totally different machines moving at completely different speeds, and yet they share this shocking paradox. Both of these incredibly high-tech marvels use the exact same word for speed, a word that originally, quite literally, meant rope.
Now, you might be tempted to just brush this off as some quirky nautical tradition that somehow survived into the modern era, but it is so much more than that. The measurement of knots is a 400-year-old invention. It was born on wooden sailing ships that had absolutely zero modern technology, no GPS, no radar, no engines, and obviously no satellites. In our modern age of jet engines and supercomputers, the world's fastest aircraft still rely on a concept invented centuries before electricity even existed. And it's not just for nostalgia, it's because the modern world has never actually found a better replacement.
To truly grasp why this stuck around, we've got to rewind the clock and transport ourselves back to the 1600s. Picture it, you're out there on a wooden ship in the middle of a vast, featureless ocean. There are no instruments to tell you how fast you're going. You basically just have to trust your gut. And back then, that was a massive problem. To a 17th century sailor, speed wasn't just about figuring out an arrival time for convenience, speed meant survival. If you misjudged your speed, you didn't just arrive late, you hit a hidden reef in the dark, or you drifted right past your only chance at land and slowly starved to death in open water.
So facing that terrifying reality, sailors desperately needed a fix. And what they came up with was this strange, incredibly clever little machine to save their lives. They took a flat piece of wood, weighted one edge with lead so it would float perfectly upright in the water like a sea anchor, and then they tied this piece of wood to a massive spool of rope. They called the whole shebang the chip lock. And the most brilliant part? It was essentially a rope designed to count itself.
Let's actually walk through how they pulled this off, because it's a very physical, tactile process that required perfect teamwork. Step 1. Hurl the wood off the back of the ship. Because it was weighted, it stayed nearly dead still in the water while the ship sailed away, pulling the rope off the spool. Step 2. Flip a perfectly calibrated 28-second sandglass. Step 3. Let the rope slide through bare hands. But remember, the rope wasn't smooth. It had physical knots tied into it. As the ship pulled away, the sailor would feel and count every single knot as it ripped through his fingers. 1, 2, 3. Finally, step 4. The second that sand ran out, somebody shouts, "Stop!"
Whatever number of knots had just passed through that sailor's hands was instantly declared the ship's speed. And this brilliantly illustrates exactly where our modern terminology comes from. If a sailor felt 5 literal knots slide through his hands before the sand ran out, well, it meant the ship was traveling at 5 knots of speed. The modern term we use today in sophisticated glass cockpits is a literal hangover from centuries ago when human hands were physically counting knots on a wet rope.
But here is where it gets totally fascinating, and where the real genius of these sailors shines through. Those knots on the rope were not just tied at random spots. They were spaced exactly, and I mean exactly, 47 feet and 3 inches apart. This is a huge, lingering question. Why would they choose this hyper-specific number? Why not space the knots an easy 10 feet apart, or maybe a nice round 100 feet? Why 47 feet and 3 inches?
Well, to answer that, we have to look at how we measure distance on land versus how we measure it on the ocean. On land, distance is entirely human-sized. Think about a standard statute mile, right? 5,280 feet. That oddly specific number traces all the way back to Roman soldiers and the distance of 1,000 marching paces. Miles were quite literally built for walking. But you can't walk across an ocean. Out there are no roads, there are no landmarks, and there are for sure no Roman mile markers. Using a land mile on the open ocean is completely useless.
So, the crucial point is that sailors needed a measurement system that wasn't based on the ground beneath their feet, but rather on the shape of the Earth itself. Our planet is a sphere, or, close enough for navigation. And as we all know from basic geometry, a circle is divided into 360 degrees. By shifting their perspective from the ground up to the globe, sailors unlocked a whole new way to navigate. Now, take just one of those 360 degrees on the Earth's surface. If you slice that single degree up into 60 equal, smaller segments, you get what navigators call a minute of latitude.
This is where the math of the planet starts to become incredibly useful for someone lost at sea.
And here is the massive aha moment that quietly reshaped navigation forever. Sailors made a brilliant decision. They defined 1 nautical mile as being exactly equal to 1 minute of latitude. With that single elegant choice, the map and the ruler became the exact same object. If a ship's captain looked at a chart and saw a distance of 1 degree, they instantly knew it equaled 60 nautical miles. No complex conversions, no messy math errors, and no deadly guessing.
Bringing it all back to that weird spool of rope, that spacing of 47 feet and 3 inches, not random at all. The sailors calculated that exact spacing so that the number of knots counted over exactly 28 seconds of falling sand would perfectly match the ship's speed in nautical miles per hour. That knotted rope was essentially the ocean's version of a ruler, intricately reverse-engineered and built to perfectly match the curve of the Earth itself.
Okay, so that completely makes sense for wooden ships in the 1600s, but it brings us to a massive question about the present day. Wood, rope, and sandglasses? Long gone. So why does a modern airline pilot, surrounded by billions of dollars of R&D, radar, and jet engines, still announce their cruising speed using a unit forged by wooden ships? It all goes back to the birth of aviation. When human flight was born in the early 1900s, there was no separate rulebook for the sky. As airplanes quickly advanced, the first long-distance flights started crossing oceans. But the only charts that actually existed for crossing those vast, featureless expanses were naval charts, which were built entirely around latitude and longitude. Early aviation pioneers, like Charles Lindbergh, had to navigate exactly the same way sea captains did, using the stars, the horizon line, and nautical coordinates.
Now, what's really interesting about this is the simple truth of early aviation. When you borrow someone's map, you borrow their math too. Early pilots didn't try to reinvent the wheel, they just lifted the ocean's mathematics straight up into the sky. And because it worked so flawlessly, there was absolutely no reason to change it.
But there is a second, absolutely crucial reason that knots have refused to disappear from modern aviation. Long flights, like a jet flying from New York to Tokyo, don't travel in a straight, flat line. They curve across the Earth's surface. Remember, standard statute miles are flat. They were built for walking on localized terrain. If you try to force flat, land-based measurements onto a giant curved planet, the math gets extremely messy, extremely fast. Knots solve this problem instantly, because by their very definition, they were built right out of the planet's geometry in the first place.
It honestly requires a complete reframing of how we think about travel. Think about your car. The miles per hour on your dashboard are just measuring how fast you are moving across the ground. It's essentially scaled up walking. But ships and planes are doing something fundamentally different. They aren't measuring the ground. They are measuring their movement across the globe, calculating their speed relative to the 360-degree sphere of the Earth itself.
So, I want to leave you with this thought as we wrap up this explainer. The next time you're sitting on a commercial flight and the pilot comes over the intercom to announce your cruising speed in knots, think about what's actually happening. You aren't just hearing a random aviation term. You are listening to a unit of measurement forged by desperate sailors throwing weighted wood into the sea, counted by human hands on wet, knotted rope, and calculated using the very curve of the Earth itself. It makes you wonder, doesn't it? The next time you fly, will you be able to feel that 400-year-old rope measuring the planet?